Okay, hi and welcome to this next video when we're looking at vectors and kinematics, and we're going to take a quick look at an example using projectiles. A bit of an overlap with previous videos with this one, but worth doing it because we're just going to look at a contextual projectiles question where we're using still our CVAT equations but in terms of vectors. So here we go, we've got a tennis player on a court. Tennis court's 24 metres long. He's hitting the ball from a height of 1.5 metres on the baseline, and immediately after the strike the ball has got a velocity. So 60i plus qj, and then there's three questions that we've got to answer. So first of all, here we go. If the ball just about clears the net, which is 1.1 metres tall, find the value of q. Right, so first things first, at the point when the ball clears the net, the components of the displacement, given in mind we'll take our point of impact as our origin. So horizontally it will have travelled 12 metres because the court's 24 metres in length, and vertically, if it was originally hit from a height of 1.5 metres and the net is at 1.1 metres, then its displacement from the point at which it was struck is going to be minus 0.4 metres. So here comes our CVAT. So there's our displacement vector, and we've got our velocity vector. There's the 60i plus the qj. V we don't know. Acceleration, it's a projectile, so in terms of I components, there's no acceleration there because it's travelling at a constant speed in the I direction, but in the J direction, clearly we've got it falling due to gravity. And T, well, we don't know the value of T. Now, I'm not going to claim that I know straight away, right from the very beginning, where I'm going to go with this one, but what I do know is that I've got displacement. So let's think a little bit about displacement and see what that allows us to do. So, often in case of questions, I find that if I just kind of think about what I can do, and then a solution kind of appears as I get partway through, as I realise what I can use within the equations. So there we go, there's our displacement formula, and we know we've got that. Okay, so now let's just have a look at what's going on. And if we just have a look at the I components, on this side here I've got 12i, and on this side I've got 60it. So let's equate those two things, because that's going to allow us to now work out the value of t, which is 0.2. And now if we go back to the j component, which is the thing I need because I'm looking for q. So if we go back to that, I've got minus 0.4j there. I've now got a value of t, so that gives me a qt there. We can work that one out. So looking at our j components now, what that allowed us to do is create an equation just in terms of q. And that's what we're after. So there we go. That gives us a value of q, which is minus 1.02. So that's part A sorted. Find the speed of the ball as it passes over the net. Well, here we go with all our bits and pieces again. And now we've got a value of t from 0.2 from the previous side. And if we go for v equals u plus at, plug those in, and we've got our components for velocity, 60i minus 2.9j. So we're being asked for speed, so therefore we're going to need to do a bit of Pythagoras, and so the ball is travelling at around about 60 metres per second as it goes over the net. Right, on we go to part C. Will it land inside the baseline on the other side of the court? So what I've done is said, well, if it lands on the other side of the court, at the point at which it lands, I know it's travelled x metres in the I component, and I know it will have travelled minus 1.5 metres in the j component because we're modelling this from when the player hit the ball 1.5 metres above the ground. So that minus 1.5 there represents when the ball hits the ground. There's our initial velocity, and there we've got acceleration, and time is the thing we don't know again. So let's go for our displacement, plug it all in, and from here we can again do this idea of equating coefficients, because if we can find the time at which it hits the ground on the other side of the court, then we'll be able to work out what our x component is going to be. So we have minus 1.5 equals minus 1.02t minus 4.9t squared. That gives us a quadratic, which we can solve. We've got a negative solution here, so that's clearly not what we need at all. So we've got our value for t. And so now let's take this value for t and go back and have a look at our x component. So our x component here is going to have to be essentially 60 times by the value for t and so that turns out to be 27.53 metres. So what's that telling us? Well, if you remember from the question, the court was 24 metres long. We've got the ball hitting the ground at 27.53 metres. So in answer to the question, no, the ball is going to land outside the baseline.